Selamat sejahtera. My name is Nadia Shafira Binti Ramli. Today I want to present my project. It's about in-vitro bioactivity of Mesoporous Borosilicate bioactive plant via titanium dioxide inclusion, synthesized by Evaporation-Induced assemble EISA technique. Introduction. A new novel technique has been used in the medical study on the broken bone tissue to speed up the development of new bone. That is called Mesoporous bioactive plants that inspired by the Hans in 1969. When mesoporous bioactive plants are deposited into the broken bone tissue, they are able to chemically interact with the tissue, which are degraded slowly over the time and encouraged to build up of carbonate hydroxide apatite (CHA) on the surface of the bone to regenerate of a new bone tissue. This process is called bone tissue engineering. In this project, the first material that we use is mesoporous bioactive plants because it has the highly mesoporous structure channel and specific surface area. It also has expanded for the drug delivery and bone regeneration application. Second is borosilicate. The bioactivity of the bioactive glass increased because the boron content in the borosilicate glass matrix. The borosilicate glass also can stimulate the fast bone formation compared to the silicate bioglass. Lastly is the titanium dioxide. Because of titan doping in the bioactive glass, it has a quicker hydroapatite formation and degrade rate usually than mesoporous bioactive glass. It also has the short time of releasing bioactive ion and the long-term lag of the oestrogenesis. The objective of this project was to prepare the mesoporous bioactive glass via titanium dioxide inclusion by salt gel with EIS technique. Second, to characterize the bioactivity properties of mesoporous borosilicate bioactive glass via titanium dioxide inclusion. For the methodology for the evaporation-induced assembly EISA technique, first we mix all the metal region for the 7 hours and transfer to the petri dish and lab the sample on the hot plate at 35 degrees Celsius for 24 hours. This process is called EIS process. After that, the sample will go through aging process, which is keep the sample at 60 degrees Celsius for another 24 hours. Lastly, the sample will go through calcinate process at the temperature 60 degrees Celsius for the 6 hours until the white solid form. To evaluate the bioactivity properties of the sample and BBGT, the sample will go through the process of stimulate body fluid in the water bath immersion at the temperature 37 degrees Celsius with the duration immersion 3 hours, 24 hours and 168 hours. First procedure is we will be pellet the sample. After that, we will take the weight of the sample before we immerse. Next, we will immerse in the water bath at the temperature 37 degrees Celsius with the immersion duration. After finish with the duration immersion, the sample will separate with the sample and solution of SPF. After that, we will take the weight of the sample after we immerse. And lastly, we will dry the sample and take the weight of the sample after it dry. The result from the sample prepared from the EISA technique, it shows the color of the sample of mesoporous borosilicate bioactive glass via titanium dioxide inclusion is equally in the brown color. This is because carbonization process during the calcinate process happen equally to all the sample. This is the result from the stimulate body fluid immersion. First analysis is the weight loss and pH level. In the figure 1A show, the graph of the weight loss of mesoporous borosilicate bioactive glass with titanium dioxide show the higher degradation after 168 hours of immersion with the weightlessness rate of 24.10%. This is because the addition of titanium dioxide speed up the rate of degradation, which is followed by slow dissolution. As a result of the addition of transition metal oxide, the system chemical durability improved. Second graph, it shows the pH level of the stimulate body fluid solution. The pH level of the glass for all the sample after 3 hours and 24 hours of immersion reveal they are higher from the initial value, which is 7.4. But after 168 hours of immersion, the pH level of the all glass sample significantly increased, which is 8.04. This is because the rapid release of calcium ions and sodium ions from the glass that exchange with the hydrogen ion from the stimulate body fluid solution caused the sharp increase in pH after 168 hours of immersion. For the second analysis is X-ray diffraction. For the all MBBG2 sample, we're coating with the amorphous structure after 3 hours and crystalline phase appear after 24 hours and 168 hours. It become more visible. The apatite was recognized as the crystalline phase, and the large diffraction peak at the 2 theta of 25.8 degree and 31.8 degree were attributed to the tiny crystalline or pulp structure. Furthermore, due to the increased aggregate in HA crystalline developed, HA peak will more appear with the time up to the 168 hours. For the conclusion of the Mesoporous Bioactive class via titanium dioxide inclusion was successfully prepared by EISA technique with different percentage of titanium dioxide. Second, the influence of percentage of titanium dioxide in Mesoporous bioactive class can observe clearly on the bioactivity properties after immersion in stimulated body fluid. Lastly, with the addition of titanium dioxide in Mesoporous bioactive class, the ionic reactivity of body in stimulated body fluid increased, indicating the increase of the bioactivity properties. That's all for me for my presentation today. Thank you.